Hi all, welcome back to our session of electromagnetic field. Already we have completed 4 lectures and today is a problem solving session and it is on the calculation of capacitance. This session is full of problems and myself Dr. Shayanti Chatterjee, the Faculty of Electrical and Electronics Engineering, the Institute of Aeronautical Engineering College, Hyderabad. And what is the course outcome? Students will be able to apply or demonstrate the behavior of conductors and dielectrics. Therefore, by computing the capacitance of different configured plates. We will discuss today about parallel plate capacitor, spherical capacitor, cylindrical capacitor, composite material capacitor, the energy using the energy stored in a capacitor. So the problems on the 5 topics. So first of all, a small description of capacitance. What is a capacitance? Capacitance is basically the ratio of amount of electrical charge stored on a conductor to a different in electrical potential. So what is this? We can write that C is equal to Q by V. What is Q? Q is the charge, electric charge stored on a conductor. What is V? V is the potential difference. It is the difference in electrical potential between 2 points. What are the units we will write? We will use the unit farad, but generally for our daily purpose we use the unit microfarad, that is 10 to the power minus 6 farad, nanofarad 10 to the power minus 9 farad, and picofarad 10 to the power minus 12 farad, and it is written by capacitance C. So today we will start the easy one, series and shunt connection of the capacitance. Already we have discussed that if the capacitors are connected in series, 1 by C total is equal to 1 by C1 plus 1 by C2 up to 1 by Cn. And what about the shunt? If the capacitors are in parallel, we can write that the shunt connection C total equals to C1 plus C2 up to Cn. Already these are discussed. And already though I have discussed this small problem before also, just revisit. So here we can see the 3 capacitors C1, C1 and C1. There are 3 capacitors are connected in. You can see C1, one is 12 microfarad, 20 microfarad and 30 microfarad are connected in series. And here you can see that the same capacitors are connected in parallel. 12 microfarad, 20 microfarad, 30 microfarad. We have to calculate the series connection as well as the parallel connection. The another name of the parallel connection is also known as the shunt connection. So in the case of the series connection, we already know 1 by C total equals to 1 by C1 plus 1 by C. The next one I write it C2. This is our C2 plus 1 by C3. So this is our C3. So we can write 1 by 12 plus 1 by 30 plus 1 by 20. So it is coming 65 plus 2 plus 3, 10 by 60. So what is the C total? C total will be 60 by 10 equal to 6 microfarad. You can get the answer. The series connection of the C equivalent is 6 microfarad. So how to do the series capacitor? We have 3 capacitors. We will take the reciprocal of each capacitor. 1 by C1 plus 1 by C2 plus 1 by C3. 1 by 12 plus 1 by 30 plus 1 by 20. So we will get it that 10 by 60 means 6 microfarad. So this is the for the series capacitance. So now we will discuss about the parallel capacitor. You can see C1, C2 and C3. Similarly, we are writing this is our C2 and this is our C3. So let C1, C2 and C3 are connected in parallel. In the case of the parallel connection capacitor, shunt capacitor C equivalent or C total equals to C1 plus C2 plus C3. We can write 12 plus 20 plus 30 microfarad. And it is coming 62 microfarad. So this is the equation of the series capacitor and shunt capacitor. So next we will discuss about the capacitance of the parallel plate. This is also in details we have discussed in the last session. This session we will just tell the what is this. You can see this is the A. A is the surface area of two plates. If two plates are placed together with some distance or some dielectric medium between them, it will some capacitance will always generate. And what is the formula of the capacitance? The formula of the capacitance is given by C epsilon A by D. And what is A? A is the surface area of each plate. A is the surface area of each plate, the top plate and bottom plate. The surface area of each plate. What is D? D is the distance between these two plates. D is the distance between two plates. So if we know, and what is epsilon? Epsilon is the permittivity of the dielectric medium, and we can write it epsilon 0 and epsilon r. So this is the dielectric material. So this is the parallel plate capacitor. So let's do a small problem. Calculate the capacitance of a parallel plate capacitor with the following details. What are the details given? The plate area is 100 centimeter square. So each plate A is 100 centimeter square. So each plate is 100 centimeter square. So as we know, we have to convert each unit. We have to convert each unit into their respective SI form. We cannot keep anything in the centimeter. We have to change it into the meter. So you can see 100 into 10 to the power minus 4. What is the meaning of 10 to the power minus 4? 100 centimeter. So centimeter to meter is 10 to the power minus 2. As this is the area, so it will be 10 to the power minus 4. So area is the 10 to the power minus 4 meter square. Next, we are assuming that it has two capacitors. We have two capacitors. So two dielectric in between the two parallel plates. One dielectric has the permittivity value epsilon R1 and another has the epsilon R2. So two slabs of dielectric is there. Now the distance, so we can draw it like this. We can draw it. This is one parallel plate and this is another parallel plate. So two parallel plate is there. Both have the cross-sectional area A. Now you can see there are two types of composite material in between this thickness. This thickness can be changed into two types of, there are two types of dielectric material. For first one, we can write the value is epsilon R1 and epsilon R1 is equal to 3, and second one is epsilon R2 and its value is given as 4. What is the distance? If we think the distance of D1, what is D1? D1 is the distance or the thickness. We can rather tell it thickness. Thickness is, the value is 3 millimeter. So first we have to convert the 3 millimeter into meter. So we are getting 0.003 meter. What is the distance of D2? What is the distance of D2? D2 distance is given as 4 millimeter. 4 millimeter. So 4 millimeter means we have to convert it into the 0.004 meter. So what we get? We get a 2 parallel plate capacitor. We got a 2 parallel plate capacitor. The total thickness is 7 millimeter. What is the meaning of 7 millimeter? 0.007 meter. Not James Bond. 0.007 meter. And we can get 2 slabs. What are the slabs? It has been, the total thickness has been divided into 2 parts. The total thickness has divided into 2 parts. One part can be is shown in this green dot. And what is the thickness of this part? The part is 0.003 meter and the down part is 0.004 meter. And one more thing, the value of epsilon R1. Epsilon R1 means permittivity of that medium is given as 3. Here the permittivity of this medium epsilon R2 is given as 4. So if we want to calculate the C1 and C2, already, so these are given. Already we know the formula. That capacitance 1 is equal, capacitance formula is epsilon A by D, or we can tell it as A divided by D by epsilon. Both are correct. We can use any of the formula. A divided by D divided by epsilon. And what is epsilon? We know epsilon is equal to epsilon 0 into epsilon R. Epsilon 0 into epsilon R. Now in this case, what is the value of A? A is nothing but 100 into 10 to the power minus 4. What is the value of the epsilon R for the first case? First case the value is 3. So 3 means we can write, and the distance is D. So D is 0.003 meter. What is epsilon R0? Epsilon R is 3 into the value of epsilon 0. If it is not given, we will take as 8.854 into 10 to the power minus 12. This is the standard value of epsilon 0. Epsilon 0 means, what is epsilon 0? Epsilon 0 is the permittivity. It is the permittivity of free space, or we can tell it as the air or vacuum. So what is epsilon 0? The value is 8.854 into 10 to the power minus 12. So if we put the value of 8.854 into 10 to the power minus 12, so we will get the value after calculation 8.854 into 10 to the power minus 11. The value is 8.854 into 10 to the power minus 11. Similarly, you can think the capacitor 2. What is the capacitor 2? Capacitor 2 is the under slab, the slab down the green one. Which one? The slab down the green striped portion. So what is the distance? The distance is given 0.004 and the value of epsilon R2 is given as 4. So C2 is equal to 100 into 10 to the power minus 4 divided by 0.004 into epsilon R epsilon 0. 4 into 8.854 into 10 to the power minus 12. So we got the value of the capacitance same because again 4 will cancel and we will get the value we will get the value 8.854 into 10 to the power minus 11. And in the both case, I forgot to write the unit is farad. Don't forget to mention the unit. The unit of capacitor is farad. Now, what is the capacitance? We can see if we connect the voltage source, if we connect the battery here, this is plus and this is minus. So current will flow from here to here. So we can say the capacitor 1 and capacitor 2 both are in the capacitor 1 and capacitor 2 both are in the series because same current is flowing in both of these. And what is the formula of series? 1 by C total equals to 1 by C1 plus 1 by C2. What is the formula? Already we have discussed. C total or C equivalent is equal to C1 1 by C1 plus 1 by C2. Then we can solve it and we will get the total value of the capacitor is 4.427 into 10 to the power minus 11 farad. So this is the first portion of this. Calculate the capacitance of the parallel plate capacitor. So how to solve this? For the each and every block of the dielectric, we will calculate the capacitor. What is the formula of capacitor? Capacitor basic formula is epsilon A by D, or we can write D by A by D epsilon Z R epsilon 0. Epsilon 0 is air and its value is 8.854 into 10 to the power 11. So individually we will calculate the capacitance of the individual part. And what is the total capacitance? Total capacitance is 1 by C1 plus 1 by C2 is equal to 1 by C equivalent. And after solving it, we got the capacitor value 4.427 into 10 to the power minus 11. So this is the first part of the problem. Now second part of the problem is if the voltage in this 2 point is 220 volt, we are connected it with a battery. We have connected it with a battery. So if we have connected it with a battery, so the voltage is given as 220 volt. What will be the voltage gradient across each dielectric? What is the meaning of voltage gradient? Voltage gradient means voltage EMF per unit length. What is this? Intensity per unit length. Intensity per unit length is called, or voltage per unit length is called as the voltage gradient. So we have to calculate the voltage gradient. So already we know the value of C. We know the value of voltage. What is the value of the voltage? The value of the voltage is given as 220 volt. So we know the capacitance value. We know the voltage value. So if what is the total charge? We know the formula. C is equal to Q by V. So what is Q? Q is equal to C into V. What is C? Already we got in the last page. It is 4.427 into 10 to the power minus 11 into V. So how much voltage we are giving? So we are giving a 100 volt. Sorry, I have taken the thing 100 volt. We have given the voltage 100 volt. So it is coming 4.429 into 10 to the power minus 9 volt. If we give the voltage 220 volt, if the voltage is 220 volt, what is the value of Q? Q will be the value C into V. 4.427 into 10 to the power minus 9 into 220. But in this problem, we have taken that voltage is equal to 100 volt. Okay. So, if it is 100 volt, we are assuming it is 4.427 into 10 to the power minus 9 volt. If the source voltage is 100 volt, we can write it is 4.427 into 10 to the power minus 9 volt. But in the case of the parallel plate capacitor, both the plates same amount of charge is there. So we know what is the value of C1 and C2. We know the value of Q. We know the value of C1. So what is the value of V1 we got? We got V1 is 50 volt and V2 is also 50 volt. So as the value of C in this problem, not for all problem, in this problem as C1 equals to C2, that's why we can write that the V1 is equal to 50 volt and V2 is equal to 50 volt. Otherwise we can calculate that V1 is equal to Q by C1, V2 equals to Q by C2. If we put the value, we can get the answer. So here we know the value of C1, we can get the answer. So what is the potential gradient? Potential gradient means voltage per length. So we also know E voltage gradient is, this is the voltage gradient. And what is the another name of this? This name is the field intensity. So what is the value? We know V is equal to minus E by D. So what is D? D is equal to, if we take the magnitude only, E is equal to V by D. So what is V? For the first case 50. What is D? D is the distance between the thickness of the plate and it is given as 3 mm. It is given as 0.003 mm. So if we calculate it, we will get the 16.66 kilovolt per meter. Similarly, E2 is equal to V2 by D2. 50 divided by 4 into 10 to the power minus 3. So these two are the voltage gradient of this problem. Next, another simple problem we will discuss. Same type of problem. So, predict the capacitance of a capacitor of two parallel plates, that is 30 centimeter by 30 centimeter, and they are separated by 5 mm. Calculate the energy stored in the capacitor. If the supplied voltage is 500 volt. So how to do this problem? What is the cross-sectional area? Cross-sectional area is given as, we know as this is the plate. Plate means we can tell this is the plate. So this is also 30. This is also 30. So as this is a rectangular or square in shape, we can tell A into B. A into B. So it will be 30 centimeter. It is given that length is 30 centimeter. So 30 into 10 to the power minus 2 meter. What is the B? B is the breadth, and breadth is equal to also 30 centimeter. So what is the value? 30 into 10 to the power minus 2 meter. So what is the cross sectional area? Cross sectional area is, what is cross sectional area? Length into breadth, means 30 into 30 into 10 to the power minus 4 meter square. So it is coming 900 into 10 to the power minus 4 meter square. So we put the value. What is the next option? What is the formula of the capacitance? Already we have discussed the formula of the capacitance, and the formula of the capacitance is, capacitance formula we know, epsilon A by D, or we can tell A by D by epsilon, or A by D epsilon 0 epsilon r. So according to this problem, what is the value of A? A is 900 into 10 to the power minus 4. What is the value of D? It is given that the D is 5 millimeter. So what is the meaning of 5 millimeter? 0.005 meter. And what is, and it is in the air. So we have the only A by D epsilon 0. So we have only D by epsilon 0, or relative relative permittivity of air is equals to 1. So A by D by epsilon 0. Now if we put the value of D, if we put the value of epsilon 0, we will get D value is 0.005. You can see the D value is 0.005 divided by epsilon 0. Epsilon 0 means 8.854 into 10 to the power minus 12. So after solving this, we got the value 16 into 10 to the power minus 11 farad. So this is the value of the capacitor. Now what is the meaning of the, so we got the value. So what is the formula of the, what is the formula of the energy? We know the energy stored in a capacitor is equal to half C V square. We know the value of V. The value of V is given as 500 square. What is the value of capacitance? Already we have calculated here. So what is the energy? The energy is given as, the energy is given as 200 into 10 to the power minus 7 joule. Next, we will discuss about the capacitance of a coaxial cable. Already in the last session, we have discussed about the capacitance of a coaxial cable, but only today we will give a brief idea of the capacitance of the coaxial cable. So you can see this is the coaxial cable, and the coaxial cable means the axis of the inner circle and the axis of the outer circle, both are equal. So we can write E equals to rho L divided by 2 pi epsilon R A R. What is rho L? Rho L is known as the line charge density. Rho L is known as the line charge density. What is the meaning of line charge density? Charge per unit length. Charge per unit length is known as the line charge density. What is R? As we know, the intensity always works in the radial direction. That's why we are writing here R. R is the radius. So the radius of the cylinder, 2 pi epsilon R. And after deducing the deduction I have told elaborately in my last session. So what is capacitance? capacitance is 2 pi epsilon L. What is the value of the capacitance? 2 pi epsilon L. Ln means log base E B by A, where L is the length of the capacitor, B is the radius of the inner circle, A is the radius of the outer circle. A is the radius of the outer circle and B is the radius of the outer circle. So let's do one problem. A cylindrical capacitor having a length of 8 cm. Similarly, as the unit is 8 cm, we have to change the unit is in the meter. So it will be 0.08 meter. It has two concentric rings with an inner surface radius is A. A is 3 cm means 0.03 meter and the outer radius of 6 cm. 6 cm means the outer radius B is equal to 0.06 meter. So already we got the 3 units. So from the previous section, we know the formula of the capacitance. What is the capacitance formula? 2 pi epsilon L. Ln means log base E B by A. And as it is no dielectric medium is mentioned, we will assume that the dielectric medium is air. So epsilon 0 is equal to air. So we can write 2 pi epsilon L log E B by A. What is B? B is equal to 6 cm. A is equal to 3 cm. So if we put the value, we will put 2 into 3.14. So this is epsilon 0. 8.854 into 10 to the power minus 12 into L. L is given as 0.08 divided by Ln. Ln is log base E B by A. Outer divided by inner. So outer is 0.08 by 0.03. So already we got the capacitor, and after solving this, capacitor value is coming 1.477 into 10 to the power minus 11 farad. So this is the formula of capacitance of a coaxial cable. So what we did in the capacitance of coaxial cable? First we will check the outer radius and inner radius, and we will change the radius unit into the meter form. And what is the formula? And we will check the length of the cylinder. So what is the formula? Capacitance is equal to 2 pi epsilon 0 L ln B by A. We know the value of 2 pi epsilon 0 as if any other thing is mentioned. Other thing means if it is except air, if it is any other dielectric material is mentioned, we will write here epsilon 0 epsilon R into L log E B by A. Next we will discuss about the capacitance of a spherical capacitor. What is the meaning of the capacitance of the spherical capacitor? Means two concentric sphere is there and the inner sphere radius is R2, which we can write is as the B, and we can write it as the A, and the inner similar to the previous, the inner is A. And what is the radius of the outer one? The radius of the outer one R1 is equal to given as B. So we have two radius, and if we keep some positive charge on the outside surface, it will induce the same amount of charge inside the coil. So if it is positive, they will give some negative value. So B is equal to minus E dot dl, and after substituting, similarly it is also told in the last class in details. We will only concentrate on this formula. C equals to Q by V. What is Q? Q equals to 4 pi epsilon and 1 by A. A is the radius of the inner surface. B is the radius of the outer surface. So let's do another problem. The parallel plate capacitors have the radii 38 mm and 40 mm. Though it is not mentioned, but we can understand B will be 40 mm. Why 40 mm? Because it is in the outside. It is the bigger means it is the outside. So R1 is equal to B is equal to 40 mm. What is R2? R2 is equal to A is equal to 38 mm. This is given. A is equal to 38 mm. And we know we will never check the formula. We will always use in the meter form, though it is not mentioned here meter, but it is the best thing. Always solve this problem change it into the meter form. So what is the formula we just read? The formula is 4 pi epsilon 0 divided by 1 by A, the lower one, minus 1 by B with the higher value of the radius. So what is the value of 4 pi epsilon 0? 4 pi epsilon 0 value is 8.84 into, what is the value? 4 into 8.854 into 10 to the power minus 12. 4 pi and 5 value is 3.14 divided by 1 by A. 1 by A means 1 by 38 minus 1 by 40. But as I told, always try to convert it into the meter form. So it will be 38 into 10 to the power minus 3. 40 means 40 into 10 to the power minus 3. So if we solve this problem properly, we can get the value of, this is AB means AB, A minus B, AB, B minus A. We can write from here 4 pi epsilon 0 AB, B minus A. So we can also write 4 pi epsilon 0 AB, B minus A. Here we are using this formula. This formula for our problem. So what is the value of 4 pi epsilon 0? We know. So this is the AB, and we got the value 84.5 picofarad. We got the value 84.5 picofarad. Now this problem has one second part. What must be the area of the parallel plate capacitor with the same plate separation and capacitance? So what does it mean? The parallel plate capacitor has the same plate changing, means B minus A is same. B minus A in the parallel plate capacitors, we can write it D, and the depth or the distance is, we can write 40 minus 38 equals to 2 mm. Now we know the value is 2 mm. What is the value of the capacitance? The capacitance value is given 84.5 into picofarad, 10 to the power minus 12 farad. We will also change it 2 into 10 to the power 3 meter. So already we know the capacitors, and we know we have to calculate the cross-sectional area. So what is the formula of the cross-sectional area? The formula of the cross-sectional area is, we know capacitors is equal to epsilon A by D. So it is CD by epsilon. What is the value of C? 84.5 into 10 to the power minus 12. What is the value of epsilon? It is in the air, so we will assume it is 8.854 into 10 to the power minus 12. And what is D? D is the distance, and distance is the 2 millimeter. So already we got D is equal to 2 mm. A we have to calculate, and this value is epsilon 0. So if, and this thickness is the distance between these two two spheres. So we can put the value 8. What is the capacitance value? If capacitor is equal to epsilon A by D, then A is equal to CD by epsilon. So what is D? D is 2 millimeter, and it is 84.5 picofarad. And what is the value? 8.854 into 10 to the power minus 2. So if we, after solving this problem, we got the value of the capacitor is 191 centimeter square, or we can write 191 into 10 to the power minus 4 meter square. So if we use the parallel plate capacitor to get the same value of the capacitance, the area, cross-sectional area will be 191 into 10 to the power minus 4. Now we will discuss about the capacitance of the isolated sphere. If two spheres are like this, we have already calculated the capacitance of this. Capacitance, in whatever capacitance we have calculated till now, it is the internal capacitance. Which capacitance is this? This is basically the internal capacitance. What is the meaning of internal capacitance? Internal capacitance means this capacitance is in between the two sphere. If we give the charge to the outer sphere, there will be some charge in the inner sphere. So this is called the internal capacitor, or the capacitance of the spherical. But as this is there is the general tendency of the charge to lie outside, to stay outside. So if some charges are on the outside, there is a general tendency of the capacitor, it outside a ball. What is this? This is the total universe. So it will try to induce some charge in the ground, in the universe also surround the charge. If this is a charge, surround it, there is an universe, and there is a general tendency to induce some charge, and it will generate some capacitance. It will generate some capacitance. So we can tell, to bring the charge from infinity to the surface. To bring the charge from infinity to the surface is called the capacitance. Okay, so if we want to bring it from the infinity, so it is 1 by A minus 1 by infinity. 1 by A minus 1 by infinity. So B, now B, for the outer one, now R1 is equal to B. This is B. We are thinking this is actually A now. We are assuming this is A now. To bring a charge from infinity to the point A. To bring the charge, so it is infinity. So the value of B, the outer radius, it is infinity. So 1 by infinity is equal to 0. So we got the capacitance value is 4 pi epsilon into A. So just the last problem we will do. Find the capacitance. I have taken the problem from one book. This is a very standard book, but as the question is very important, that's why I am discussing the question. Find the capacitance of the conducting sphere of 2 cm in diameter covered with a layer of polyethylene with the epsilon r 2.26 and 3 cm thick. Okay. So we have two formulas in our hand. What are the formulas? First, we will think there are two capacitors. And what is the thickness of the capacitance? According to this problem, this is 3 centimeter thick. So what does it mean? The radius of the conducting sphere is 2 centimeter in diameter. So what is the diameter of the inner one? It is given as 2 centimeter. Diameter is 2 centimeter. We want the radius. So what is the radius? Radius is 1 centimeter. The radius is 1 centimeter. And what is the value of the, then what will be the radius, as this is the 3 centimeter. 3 centimeter is the thickness. So what is the radius of this? The radius of this one, B, is equal to, this is our A. What is the value of B? 1 plus 3. 3 is the thickness. So it is the 4 centimeter. So we got the, so what is the value? 4 pi epsilon 1 by A minus 1 by B. And what is the layer? This layer is made of the polyethylene. So epsilon value is given 2.2.6. So we can write 4 into 3.14 into 8. Epsilon means now epsilon 0. Epsilon is now epsilon 0. Epsilon r. What is epsilon 0? Epsilon 0 value is given as 8.854 into 10 to the power minus 12 into epsilon r value is given as 2.26 divided by 1 by A minus 1 by B. B means 4. So already we got the value of this capacitance and we can write it capacitance for the spherical. Now you think there is an outer also. In outer, this is a ring, and according to the outer sphere, you can see the outer sphere. What is in the outside? Outside is equals to the, what is in the outside? Outside is basically the universe. So with respect to universe, this is also a sphere, and we will assume it as the isolated sphere whose value is 4 pi epsilon A. So what is the value? The value is 4 pi epsilon. Now what is A? Now A is basically nothing but this radius. Now it is the inner radius. Now I will show you. Now this green one is the inner radius, and so what is the outer radius? Outer radius is the infinity. So it looks like this. We are taking only this. And what is the radius of this? The radius of this is 4 centimeter. This is our A. So 4 pi epsilon A. So it is 4 pi. 3.14 into epsilon. It is outside, this is nothing means it is air. So we will take it as 8.854 into 10 to the power minus 12 into A. What is the value of A? A is the 4 centimeter and we will convert it into the meter. So 4 into 10 to the power minus 2. So we can say this is the spherical and this is for the isolated. So just one small revision. When we are thinking about this type of spherical, we will assume two types of capacitor. Which one is the inside and it is like this normal spherical capacitor, and the outer sphere is also behaves like a capacitor with respect to the ground. We get the example of the overhead lines. In the overhead lines, you can see that there is some capacity property of the overhead lines with respect to the ground. So we got one C1 and C2, and you can see if we connect the battery here, we can assume these two are in the series. So C spherical is series with the is in series with C isolated. So what will be the formula? The C equivalent will be C spherical into C isolated divided by C spherical plus C isolated, and these two capacitance are in parallel. So we can write this is the we already got the value, and we got the, if we put the value, we will get the answer of 1.9121 picofarad. 1.9121 picofarad. Picofarad means we can write it as the, we can also write 2 into 10 to the power minus 12 farad. Just putting the value. So what we are doing? We are first calculating the internal capacitance, and internal capacitance with the epsilon R value is given as 2.26, and then we have calculated the external also, and external value is given as it is a 3 centimeter diameter, so it is 1 plus 3 means 4 centimeter radius. So we calculated the C isolated using the formula 4 pi epsilon A, and here A is the, what is A? A is the radius of the external. Here A is the radius of the external. Here A is the radius of the internal. Now we will assume that the both of these are in the parallel form. So in the series with each other. If we connect one battery, both are in series. So we can write that the C equivalent is equal to C spherical into C isolated by C spherical. So we will get the answer 1.9121 picofarad. So today we have discussed some problems of the capacitance. Please check the problems, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.